Cambridge IGCSE Physics Paper 2 Multiple Choice Extended October-November 2025 Paper 22. Which quantities are both vectors? Vectors are quantities that have both magnitude and direction. Acceleration and force, yes, that's correct, because acceleration is the rate of change of velocity and velocity is a vector. So that means acceleration is also a vector, and force is basically the force you apply in a specific direction. Okay, so basically a weight is a force. So you know that weight is always downwards, the direction is downwards. So that's why both are vectors. Acceleration, pressure. Acceleration is a vector, but pressure is a scalar. Density is a scalar. Force is a vector. Density is again scalar, and pressure is again scalar. How is the deceleration of an object calculated from a speed time graph, the gradient of the graph? Because you know that this is your speed, so meters per second, and that's your time. And you know that the gradient of a velocity time or speed time graph tells you the acceleration. Why the gradient tells you acceleration? The gradient basically tells you the rise over run. Rise is your velocity, change in velocity, and run is your change in time. Run means this side, the vertical, the horizontal one, and rise means the vertical one. So v over t, that gives you acceleration or the deceleration. So basically the gradient of your graph. So it is the area under graph gives you the displacement or the distance, the gradient of the graph. It is the difference between the two readings on the horizontal axis. No. On the horizontal axis, the difference between the readings is going to give you what? Is going to give you the change in time. And on the vertical axis, the difference in reading is going to give you the change in velocity. So if you divide the difference of the readings of the vertical and on horizontal, then you get the acceleration. So it's the gradient. A space probe that has a mass of this is on planet Mars. The acceleration of free fall on Mars is this. What is the weight of this space probe in Mars? Okay, so weight equals to mg, where m is the mass, that is 600, times g. G is the gravitational field strength, which is 4 meters per second. So if you multiply it, 64 times 24, 00 Newton. So 2400 newtons is gonna be your answer. Simple and easy. Students are asked to predict the order in which three liquids P, Q, R will float on each other. They are told that the liquids will not mix. So because of difference in densities, the liquids are gonna float. The diagram shows how the density of liquid P is determined. So we know the formula of density. Density equals to mass upon the volume. Okay, so I guess over here first they're gonna find the mass, electric balance of the empty measuring cylinder there, then they add the liquid into it, then measure the mass, then subtract the two masses, and they're gonna get the mass of the liquid. The table shows the densities of Q and R. Done ho gaya. The liquids are then poured gently into a tall beaker and allowed to settle, which diagram shows the liquid settled on top of each other. Okay, first we need to find the density of liquid P. Density equals to mass into volume. Firstly, mass is going to be 69 minus 45. So mass comes out to be 24 grams upon the volume. I am going to take in cm cube. You can see this is a measuring cylinder and this tells 20 cm cube. So 24 divided by 20, go to the calculator. So 24 divided by 20 gives you 1.2 gram per cm cube. So what's going to happen is the least dense is going to be at the bottom. So we know that liquid P is going to be the most dense. Sorry, the most dense is going to be at the bottom. So P is going to be at the bottom. Above that, it's going to be R, which is a little less dense, and at the top the least dense is going to float, because you know that the less dense you are, the more above you are, right? You can float above with less density, and if you have greater density, you're going to sink. So that's the order. A force F is applied to a spanner as shown. So we have a spanner, we are going to apply a force that's going to create a moment, and this nut, I guess this is going to be our pivot, because it's not going to move from here, and we're going to apply some vertical force downwards, which action increases the moment of F about the center of the nut. Applying, so okay, good. Write the equation of moments. You want to know that how are you going to increase the moment? Moment equals to force into distance. This distance is the perpendicular distance from here to here. Applying the force F to the right hand end of the spanner handle, that is correct, because if you're going to apply the force here, what is going to happen to this distance? Look it for yourself. The distance is going to increase, because like if I say that this entire is, for instance, 10 centimeters, until here it's 7 centimeters. So over here, when the distance going to increase, it's going to become 10 centimeters. What's going to happen? Your moment is going to increase, because moment is force into distance and force is constant. So if you're going to increase the distance by applying the force from a little left, the moment's going to increase. So option A is correct. Applying the force parallel to the spanner handle. Parallel? Like this. If you apply the force parallel to the spanner handle, you know what's going to happen? See it for yourself. If you apply the force in this direction, the line of action of force is going to pass from the pivot. So the perpendicular distance between the line of action, force, and pivot is going to be 0. So you're going to have 0 moment. Spring oil in the nut. That's going to increase the fluidity. That's going to make it move easily but not increase the moment. Use a short spanner. Short spanner means you're going to decrease the moment. You know why? Because what's going to happen is that shorter spanner is going to decrease the distance, and moment is only dependent on two things, either increase the force or the distance, nothing else. Oil, vagera, nothing is going to affect it. Okay, so diagram 1 shows a ball X of mass this traveling horizontally with the velocity of this towards ball Y traveling at this in the opposite direction. Diagram 2 shows the velocities of the balls immediately after they collide. What is the mass of ball Y? Okay, so first things first, conservation of momentum. Okay, so we know that this is 0.15 kilograms. This is gonna be M. This again is 0.15 kilograms. Kilograms now, and this is M. First, I'm gonna, before collision, so diagram 1 is representing my momentum before collision. Done ho gaya? So momentum equals to mass into velocity plus mass into velocity of the second ball. So I'm considering right to be positive and left to be negative. So the mass is going to be 0.15 multiplied by the velocity towards the right, 2.1, plus mass m multiplied by the velocity which is towards the left, negative 0.4 meters per second. So if I solve it, what's my expression for my total momentum before collision? It's 0.15 times 2.1. 0.15 times 2.1, 0.315 negative 0.4 m. Okay, before collision, after collision, what's happening is this ball is traveling towards the left. So 0.15 multiplied by negative 1.4 plus this is traveling towards the right, 1.1 m. So 0.15 multiplied by 1.4 and that gives me 0.21. So negative 0.21 plus 1.1 m. That's my total momentum before collision. That's my total momentum after collision. I'm gonna equate the two momentums to get my net value of m. Okay, so 0.315 minus 0.4 m equals to negative 0.21 plus 1.1 m. 0.315 plus 0.21 equals to 0.4 m plus 1.1 m. Quick, 0.315 plus 0.21 gives me 0.525 equals to 1.5 m. 0.525 upon 1.5 equals to m. I get 0.35 kilograms as my answer. Simple, easy. Option number C. Got it? Momentum before collision equals to my momentum after collision. Just had to be careful about the directions. You had to take one is positive, other is negative, and then you had to solve this. A mass is suspended from a vertical spring. The mass is pulled downwards, causing the spring to extend further. The mass is held in this position and then released. Which energy changes occur during the initial movement of the mass when the mass is released? Okay, so this is your spring, you have to imagine. This is your mass. Now when this mass is going to be released, this spring is going to uncoil, right? This spring is going to not uncoil, it's going to move upwards. So when it's going to move upwards, the gravitational potential energy is going to increase because you're gaining height, you're moving upwards, so it's going to increase. Kinetic energy, since it's going to accelerate upwards, it's going to move upwards, it's going to be like, just imagine you have something pulled down from a string and then you release it. Then what happens to the spring? It moves with a lot of speed, it accelerates upwards. So it's gonna increase. An elastic potential energy, since the stretch is gonna reduce. Firstly, it was more stretched, and when you release it, it's gonna be less stretched. So the elastic potential energy is gonna decrease. You just have to imagine that you have a spring that's unstretching. Which energy resource stores kinetic energy? Stores kinetic energy. Coal stores chemical energy, and then you burn coal, and then that chemical energy converts into thermal energy. Nuclear fission stores nuclear energy. Solar stores light energy or the radiant energy. And kinetic energy, because wind moves and then it makes the turbine move. Wind moves. Okay, two beakers are filled to the same depth, one with water and one with oil. The density of water is this, the density of oil is this. Water is more dense. At which position is the pressure greatest? Firstly, pressure equals to rho gh. So greater rho means greater density means greater pressure. So we're going to cross out oil because oil has less density. So now we're just going to look at water. Position A or position B? Position B, second thing that pressure depends on is your height. You should have greater height. Position A has less height. Position B has greater height. So the answer is going to be B. B is going to have the greatest pressure, and the least pressure is going to be at C. And I hope you understand why. Okay, the pressure of the air in car tire rises after a long journey because there's going to be friction, the car tire is going to heat up, and when it heats up, what happens that the air gets heated, particles gain kinetic energy, exert more pressure, more force. This is caused by a change in the average speed of the air particles and the change in the temperature. We know this. Which row describes the changes that have caused the air pressure in the tire to rise? Average speed of the particles increases, temperature of the air increases. Simple. Because whenever you heat particles, their speed is going to increase, and temperature is also going to increase. Okay, in which range of temperatures is water a liquid? Water at liquid. 0 Kelvin is very low. 278 Kelvin is your RTP. So at RTP, water is a liquid. So 0 to 9, 100 to 9 D, because 278 is in between over here. And if you have a lot of problem, you can convert, but I don't need to convert. Just by looking, I can tell that my 278 is gonna lie over here. So over here it's gonna be a liquid. But if you want to convert, just subtract. You know that at 0 degrees water is almost like solid and liquid plus. So after 0 it's 1 degree to almost your 99 degrees, I guess. So you can convert it by adding 273 to it and just see what happens. The diagram represents the particle arrangement in samples of 3 different substances, P, Q and R. Q is a solid, P is a liquid, R is a gas. The samples have equal volumes and the same temperature. The samples are heated. The temperature increases of each sample in the same, and no changes of state take place, which shows possible percentage increase in the volume. You should know that gases expand the most. After that, why gases expand the most? Because which possible increase in volume? So the greatest increase in volume is going to be in gas. So sample of R is going to have greatest. After that is it's going to be P, because after gases liquid's going to expand, and the least expansion is going to be observed in solids, because that's the order of expansion. Because in gases there are more spaces and there are weak intermolecular forces. Because of that, the particles have the kind of audacity to expand. So 7.2, then for Q it's going to be the least, and for P is going to be more, because P is a liquid. Got it? A cup contains this much of water at this much temperature. So we have mass, we have temperature. Sometime later the water is cooled to this, so that's the change in temperature is going to be how much? 40 degrees Celsius, I guess. How much energy has been transferred from the water to the surroundings? Q equals to mc delta T. Mass is 0.25, C is 4200, I guess, and delta T, which is the change in temperature, is 40. So 0.25 into 4200 into 40. 0.25 into 4200 into 40, 42,000. Option number B. You simply have to use the formula Q equals to mc delta T. C was given, delta T to be calculated, and m was the mass. A pure substance is the one that is a fixed melting and boiling point, is heated slowly. This is feeling more like a chemistry paper than a physics paper, because of a lot of thermal energy questions. Okay, the temperature of the substance is measured as it starts to melt, and when it finishes melting, melting, freezing, boiling all happen at a fixed temperature, so the temperature is not going to increase. The temperature decreases slightly, the temperature remains the same as the substance melt. Pure substances melt, boil, freeze at same temperatures. So during the time pure ice is melting, the temperature remains 0 degrees Celsius. It doesn't increase, it doesn't decrease. Gotta remember this thing. Got it? A lamp has a metal filament that glows when heated by an electric current. The middle of the filament is at a very high temperature. The ends of the filaments are connected to the base of a lamp and a cooler. Which statement is correct? Some thermal energy is conducted to the base of the lamp. Okay. Because it's cold, energy flows from hot to cold regions. Am I correct or incorrect? I guess I'm correct. So this is correct, that it should flow to the base because the base is cool. So this can be correct. The filament radiates energy equally at all points along its length. Nahi. The points that are cooler, it's not going to radiate at that point a lot. The lamp transfers all of the input energy is visible. No, it's getting heated. Not all energy is converted into light. When the potential difference across the filament is halved, the power output is halved. No. Look, P equals to V square upon R. I say that my R is constant. The relationship between power and V is not a direct relation. Power is directly proportional to V square. Got it? So when the power output is going to be halved, what's going to happen to V? It's going to be 1 upon 4 times. It's going to decrease 1 upon 4 times. If this is going to half, this is going to decrease 1 upon 4 because the relation is not direct. P is directly not proportional to V, but the square of V. V is the potential difference. So if the power output is half, the potential difference is going to decrease by 1 by 4. Got it? Got it? No direct and inverse relation. Oh my god, a lot of thermal questions. Okay, liquid passes through pipes inside a refrigerator. So I guess that's gonna involve some kind of convection or conduction, maybe. The liquid warms as the inside of the refrigerator cools. So the warm liquid is then passed through the pipes on the outside of the refrigerator to cool it before it goes back through the refrigerator. So what we're doing is that we have warm liquid and we're making it like move here, and then we get cold liquid out, and then what we're doing, we again have warm liquid, we're trying to cool it. The diagram showed two designs for the outside cooling pipes. So one design is this and one design is this. Definitely this design is gonna work, this design is not gonna work because it needs to cool. How can it cool? If it transfers its heat energy to something else, so it's going to transfer its heat energy to the fins, only then it can cool. The outside pipes and fins can be painted silver or black. Which design of the outside pipes will cool the liquid most quickly? Painted black with fins. Yeah, that's correct. So if the outside pipes are black, then what's going to happen is they're going to release heat energy more quickly, because black color is a good radiator, it radiates heat energy, so they're going to quickly release the heat energy to the fins. If they're painted black without fins, they're going to release it to the surroundings. That's going to take a lot of time, but if they release it to the fins, that's going to be quicker. Silver is not going to help, because if it's silver, it's not going to release the heat energy. The warm liquid is going to remain warm. Got it? An earthquake monitoring station records the arrival of 16 complete wavelengths of an earthquake in a time of 20 seconds. The speed of the earthquake wave is known to be this. What is the wavelength of the earthquake wave? V equals to F lambda. Frequency, if 16 complete waves complete in 20 seconds, then in 1 second, how many waves are going to complete? X, that's going to be 16 upon 20. Frequency is going to be 16 upon 20. 16 upon 20. That gives me 0.8 hertz. So frequency is 0.8 hertz. And my speed is 6 kilometers per second. I'm going to convert it into meters per second because all my answers are meter. So that's going to be 6,000 meters per second divided by 0.8 is going to give me the value of lambda. Lambda is the wavelength. 6,000 divided by 0.8. 7,500 meter. Easy. Which statement is correct? Seismic S waves are longitudinal. Asha, this is the part that you got to learn. You got to learn it from the syllabus. Sound waves are longitudinal. That is what all of us know. Sound is longitudinal. So just let's select the right one and move on. A water droplet is falling towards a horizontal plane mirror. So we have a horizontal plane mirror, something like this, I guess. And then a water drop is falling towards it. At one moment, the drop is at a distance of 1.5 meter above the mirror and falling at a speed of 2 meters per second. So that's the distance above the mirror, that's the speed. What is the distance between the drop and its image, and what is the speed of the image at this moment? Speed is not going to change. I don't think mirror can change the speed, but the distance is going to be double, because when you see yourself in a mirror, you're going to see yourself here. The drop is going to see itself here. So there's going to be this distance, and then there's going to be this distance behind the mirror. So that's why when you touch the mirror, you feel like someone behind from the mirror is touching your hand. That's actually you touching your hand, but you see yourself that much distance away from the mirror. Got it? The total internal reflection may occur when light reaches an air glass boundary. Yeah, that's correct. Under which condition is light totally internally reflected? Medium in which light travel towards the boundary. So you know the total internal reflection occurs when this is your glass and this is your air, and the light is moving from a more dense medium like glass towards air, and if this angle is greater than the critical angle, it's going to move back. So medium in which the light travel towards is going to be glass. Angle of incidence, it should be greater than the critical angle. Only then it causes total internal reflection. At critical angle, the reflected wave, it just exactly lies on the boundary. But as you increase the incident angle a little more, a little more than the critical angle, the wave does total internal reflection. What is the speed of infrared radiation in the glass of refractive index 1.5? So n equals to c upon v. C is the velocity of the light or the electromagnetic radiations in vacuum, which is 3 into 10 raised to power 8 upon v equals to 1.5, which is the refractive index. 1.5 comes down here, v comes down here, so 3 into 10 raised to power 8 divided by 1.5 is going to give you the velocity, the new velocity. And if you put it in calculator, you are going to get 2 into 10 raised to power 8. So this is the formula that you have to learn. Over here, n is basically your refractive index, c is the velocity of light in vacuum, and v is the new velocity that you want. Sound travels through air as a series of compressions and rarefactions. Which statement correctly compares a compression with a rarefaction? Compression is a region where air particles are closer together, so there is high pressure, and rarefaction is a region where particles are far apart, so there is a low pressure. In a compression, the wavelength is longer than in a rarefaction. No, the wavelength remains the same. In a compression, the wavelength is shorter. No, the wavelength doesn't affect. It's basically over here, particles are closer. Over here, particles are far apart. In a compression, the density of air is greater than in a rarefaction. Yeah, that's correct. What is density? Density is mass per unit volume. When there are going to be more particles, if we take the same volume, okay? So we take this much volume here and this much volume here. So the volume over here and here is the same. But the problem is that there is more mass over here in a compression. And if there is more mass in a compression, then that means the density is going to be greater because the volume is the same. So that's why there is going to be greater density. In a compression, the density of air is lower. No, in a rarefaction, the density of air is lower. In a rarefaction, the density of air is lower. Which statement about magnets are correct? Permanent magnets are made of steel. Yeah, that's correct. Steel is used to make permanent magnets. Electromagnets are temporary magnets. Yeah, when you pass electricity through them, they magnetize. And when electricity source is removed, they demagnetize. A magnet can be used to induce magnetism in an iron bar. Yes, iron bar is a very good temporary magnet. So what you can do, you can induce magnetism to it, and when you remove the magnet, the magnetism is gonna like go away. So 1, 2 and 3, it magnetizes and demagnetizes easily. In a circuit, two identical lamps are in parallel. So the parallel pair of lamps is in series with a resistor and a battery. So we have two lamps that are parallel like this. So these are the two lamps that are in parallel. The parallel lamps are in series with the resistor. So we have in series with a resistor and a battery. So that's the battery. Done. The battery does 120 joules of work, moving 50 coulomb of charge around the circuit in time t. So it's doing 120 joules of work, moving 50 coulombs of charge. So work done per unit charge, that is the EMF of the battery. You know that the formula for voltage is work done per unit charge. So work done is 120 joules and charge is 50 coulombs. So what's going to be the EMF? 120 divided by 50. 120 divided by 50, and that gives me 2.4. So 2.4 volts is the EMF of the battery. In each lamp, 40 joules of work is done by the charge that passes through it in time t. So 40 joules work is done in each lamp. Okay, 40 joules here, 40 joules here. 40 joules work here is done, 40 joules work here is done. Okay. The EMF of the battery and the potential difference across one lamp is V. Okay, the EMF of the battery is E and the potential difference across one of the lamp is V. The potential difference, if it's V across one of the lamp, then on the other lamp as well it's going to be V, because you know that in parallel the potential difference remains the same. So which statement is correct? EMF we just figured out is 2 volts. And V is 0.8 volts and V is 1.6 volts. To figure out V, we know that voltage equals to work done upon the charge, right? If 2.4 is coming from here, 2.4 volts, it's gonna remain 2.4. But remember one thing, that the charge is gonna go half over here and half over here, right? Because entire charge cannot pass through a single resistor. Charge is gonna divide. So this 50 coulomb of charge, 25 is gonna go in the upper resistor, in the upper lamp, and 25 in the lower lamp. So 40 joules of work is done by 25 coulombs of charge. Got it? So voltage equals to work done upon charge. 40 joules of work is done by 25 coulombs of charge in each lamp, because the 50 coulombs of charge that is initially going to travel from here is going to divide like this. So 40 divided 25, that gives me 1.6 volts. Got it? So this is going to give me 1.6 volts, which is option number B. Got it? Two wires X and Y are made from the same metal and have the same resistance. Which row identifies a possible pair of values of X and Y? If they have the same resistance, resistance equals to row length upon area. Instead of area, you can write diameter pi d square upon 4 upon L, rho equals to resistance. So over here, we have to figure out a pair in which length divided by diameter square remains the same. So over here, 50 divided by 0.4 square should be equal to the same number, which is going to be equal to this. If I do the same with this, because you know that 4 and pi are constant, rho is constant, resistivity. So what's changing is length upon d square. So I need this to be constant for both wires, because ये तो पहले ही constant है, क्योंकि वो same material के हैं. So rho is going to be constant, pi is going to be constant, 4 is going to be constant. That's not going to change. What's going to change is L and d square. So to make them the same for both wires, I have to do it 50 upon 0.4 square. 50 upon 0.4 square, 312.5. So over here I get 312.5. 200 divided by 0.1 square. 200 divided by 0.1 square, 20,000. 20,000. Incorrect, because this and this are not equal. I want them to be equal. 50 divided by 0.4 square, this is going to give me 312.5, 312.5 and 312.5. Now 200 divided by 0.2 square. 5,000. Incorrect. 200 divided by 0.8 square. 312.5. Over here I got 312.5. So this is gonna be my answer. Did you guys understand what I did? I just tried to make L upon D square constant Why did I try to make this part constant? Because for both wires, rho pi 4 were already constant. So I just had to make this part equal so that the resistance of the both wires could be equal. I hope you got it. This one was a little trickier for IGCSE, but it's fine. Which circuit contains an LDR? This is a variable resistor, this is a thermistor, this is a heater, and this is a LDR. So it's option D. We can write this is variable resistor, this is thermistor, which depends on heat, this is a heater, and this is an LDR. There's one other thing, that is LED, light emitting diode, which is something, I don't know the exact, but it is something like this, and then there's light coming out. So learn that as well. A teacher asks 3 students to write down an equation to determine the combined resistance RC of the 3 resistors of the resistors RY and RZ. Which student is correct? Okay, so for parallel, you know what happens. 1 upon RC, which is the combined resistance of this and this. So 1 upon RC is going to be equal to 1 upon the resistance of this, which is RZ, plus 1 upon the resistance of this, which is RY. So this is correct. This, now let's look at this. So if we try to combine the two, 1 upon RC equals to RZ plus RY upon RZ RY. So this is incorrect. This is also incorrect, because if you have taken a reciprocal on this side and brought RC on the top, you have to take a reciprocal here as well. So this is incorrect. This is also incorrect, because the correct way, if you are going to solve it, it's going to become this. Simple mathematics. So only student 1 is correct. An electrical appliance has a symbol on it to indicate it is double insulated. Okay. There's a symbol on wire that tells that there is double insulation on the wire to protect the person from like electric short. Which statement is correct? A 2-core flexible cable with no earth wire is used to connect it to main supply. Yeah. Whenever you have double insulation, you don't need earth wire because you're protected. So this seems correct. It needs an earth wire. No earth wire needed. No fuse or circuit breaker. Circuit breaker is still needed. Fuse or circuit breaker is basically not to prevent you from shocks. Fuse and circuit breaker is to prevent the appliance from getting damaged if a lot of current passes through it. So you need a fuse. The cable should be connected to the live and earth connectors of the plug, but not the neutral. Neutral wire is always needed. A length of a wire moves across a space between the poles of a magnet. The voltmeter measures the EMF generated when the two ends of the wire. So you know that's Faraday's law of electromagnetic induction, that which will give the highest voltmeter reading. So the more the rate of change of flux, the more voltmeter reading. So wire should move fast, and the strength of the magnet is going to be obviously strong. That's going to give you the highest reading. That was easy. Okay, so now the diagram shows a simple AC generator. What is connected? Okay, that's alternative current supply is going to be produced here. What is connected to G and H so that alternating current can be provided to an external circuit? So you know that there are 2 types of rings, slip rings and slit ring commutator. In an AC generator, we use at G and H slip rings, and in a DC generator we use slit rings. So there's a small difference. You need to learn it. Then the diagram shows the coil in a DC motor in 2 positions. Okay, there are 2 positions. As the coil rotates, so this is a DC motor, not an AC. As the coil rotates through 180 degree, the direction of the current in the coil reverses from PQRS to SRQP. From PQRS to SRQP, yes, we know it's going to reverse. Which part of the motor is responsible for reversing the current? Again, the split ring commutator does it. It's like something like this. I am not sure, but something like this. It just keeps on reversing it. You better see an animation of split ring commutator, and then you're gonna realize that how does it does this. So this is the part that's responsible. The brushes, the carbon brushes, they just conduct the current. The coils, they are just there to for the current to flow, and the magnets are there to induce the kind of current. But split ring commutator reverses it. Okay, the arrow shows the part of an alpha particle traveling towards the center of a gold nucleus. That is a gold nucleus alpha particle scattering experiment. You should know which description of the path of the alpha particle after striking the gold nucleus is correct. So you know alpha particle is positively charged and a gold nucleus is also positively charged. So what's going to happen, there's going to be a force of repulsion between the two. The alpha particle is deflected through a very small angle towards the top. No, by large angle is deflected back along its initial path. Yes, I think this is going to be correct because there's going to be so much repulsion between the two that it's going to repel backwards along its initial path like this. The alpha particle carries on in a straight line. Why would it carry on? There is repulsion between this and this. The alpha particle is captured by the nucleus. No. Okay. A teacher writes the nuclear notation for a fusion reaction. So this and this are fusing to form this and this. So there's going to be a 2 here because these are fusing. So obviously this. What is missing? Number X and Q. Where is Q? Q is helium. Obviously 2 hydrogens are going to fuse together to form helium. Helium has a proton number of 2 and a mass number of 4. And there's going to be a 2 at the place of X. If you don't get like this, what you do, you just add this fella and this fella. Adding them is going to give you 4. So you know 2 plus 2 is going to be 4. Okay, radon gas is a source of radiation that contributes to background radiation. What does not contribute to background radiation? I guess it's gonna be D. Yeah, seismic waves, they're like the waves inside your earth, I guess. So why would they contribute to background radiation? And they're longitudinal waves. They're not like the nuclear kind of radiation thing, no. Okay. 2 beams of radiation P and S enter an electric field as shown. We can see P is being deflected to the positive side. So P is something that is negative. So definitely it's going to be beta. And we say that S is deflecting towards the negative side. So S is going to be something that is positive, which is alpha. If it were gamma rays wouldn't deflect. They'd pass straight like this. And now you can see one more thing, that beta is deflecting more, alpha is deflecting less. Why? Because alpha is heavier. Heavier particles are going to deflect less, whereas lighter particles are going to deflect more. You just take an example. If there is a person that has a mass of 1 kg, okay, and if there's a person that has a mass of 100 kg, okay, think about it. If the wind blows from here, okay, there's very strong wind, this person is going to be blown away by the wind, but this person is not going to be blown because he's heavier. I'm not doing body shaming here. I'm just telling you, if someone is heavier, it's difficult to move them. So that's why it's difficult to move alpha. That's why it's deflecting less. What change takes place in the nucleus when it decays a beta emission? During a beta emission, a neutron basically converts into a proton and an electron. And that electron is what you see that comes out in the form of beta emission. A space probe measures the gravitational field strength at 4 different distances from a planet. The point furthest from the planet is measured first. So it's going to have the lowest gravitational field strength. Why it's going to have the lowest? Because the further you go, the gravitational field strength weakens, and the point nearest the planet is measured the last. So nearest the planet it should be the highest, and furthest from the planet it should be lowest. So like this is increasing order. So this is going to be correct. Why? Because look, over here it's decreasing, it should decrease. Over here it's increasing, it should increase, because from here the gravity is going to be less. But when you move closer, this is your planet. So the closer you move to the planet, at the surface it's going to be 20, but at very top it's going to be 6.3. So the farthest you go it decreases, the closer you come to the planet it increases. Okay, the galaxy Draco 2 is at a distance this meter from the Earth. What is the distance in light years? Okay, So first you have to find the distance of 1 light year. 1 light year means that distance equals to speed into time. Speed of light is 3 into 10 raised to power 8 into uh, time of what do we call it? Time of 1 year. So we have 365 days, we have 24 hours in one day, and we have 60 minutes in 1 hour, and then we have 60 seconds in one, what do you call it, in 1 minute. And after that, how much distance is 1 light year? So this is the distance of 1 light year. Light travels this much distance in 1 light year. So this much distance divided by the distance of 1 light year is going to give me how many light years? So 6.6 into 10 raised to power 20 meters divided by the distance of 1 light year, which is 9.4608 into 10 raised to power 15. Let's see, what do we get? 6.6 into 10 raised to power 20 divided by 1 light year. It is giving me 6.976 into 10 raised to power 4. So that makes it option number B. Got it? It was easy, very easy. You just had to calculate the distance of 1 light year and divide your total distance by the distance of 1 light year to get the number of light years. So light has to travel these many years to get to Draco. Oh my god, we'll be probably dead up. Like, no human can ever live up to 69,761 years. No one can ever live like this. So probably if we send light today to Draco 2, when we'll be rotten in our graves, when we'll be like, probably the world will be destroyed by asteroids and there's going to be no one left. At that time, light will reach Draco 2. And if today you see any light that's coming from Draco 2 that probably left the planet 69,000 years ago, and today it reached you. So that means by now might be the galaxy, the star from which you're getting the light might be destroyed in a supernova destruction, but still you can see it, despite in reality at that point in time it's destroyed, but you can see it. Why? Because when you see stars, you are seeing 69,000 years in past, because the light that left the star, it took 69,000 years to reach you. So when you look there, you're looking back in time. Got it? What is the possible result of a supernova explosion? It results in a neutron star that is extremely dense. It's so dense that a spoon of a neutron star is going to be heavier than your entire solar system. It's that dense. A red giant star, a red supergiant star, a white dwarf star. No, it's a neutron star. Got it?